Welcome back. In our previous session, we have covered computer maintenance and security, device drivers and antiviruses. We have also discussed the concept of disk cleanup utilities. Also, we have covered computer diagnostic programs like DirectX. So in this session, we are going to discuss fragmentation and compaction. So if you recall, in the previous session, we briefly discussed about the fragmentation concepts. So fragmentation and compactions, they are the fundamental concepts in computer science, particularly within the realm of memory management and operating system and storage system. These terms describe how data is organized, stored, and managed within the memory, for example, in RAM, or storage devices like hard disk drives or solid state drives. So, fragmentation refers to the phenomena where data is scattered across non-continuous memory location, leading to inefficient use of space. Compaction, on the other hand, is a process of reorganizing the data to consolidate the fragmented blocks and improve the memory utilization. So, proper management of fragmentation and compaction is essential for optimizing the system performance. By reducing the fragmentation and improving the memory utilization, compaction can enhance system responsiveness and overall efficiency. Preventing performance bottleneck, fragmentation can create performance bottleneck, especially when dealing with large data sets or intensive workloads. So proper compaction can help overcome these bottlenecks. In the same way, maximizing resource utilization. So by efficiently organizing data, compaction can ensure that the memory or the storage resources are used effectively, preventing the unnecessarily waste. So now let's discuss what are the types of fragmentation. So as we have discussed earlier, that fragmentation is a common phenomenon in computer systems where available memories or storage spaces, they are divided in small non-continuous chunks. So there are two primary types of fragmentation, internal as well as external. So internal fragmentation arises when a memory block allocated to a process is basically larger than the actual memory required by the process. So this discrepancy resulted in unused spaces within the allocated block, which is considered wasted. So what is the primary cause of internal fragmentation? So there are many reasons which includes the fixed size allocation. So when memory is allocated in fixed size blocks, regardless of the actual memory requirement, so internal fragmentation can occur. For instance, if a system allocate in 4 KB block memory and any processor requests less than 4 KB block, so basically what will happen that the remaining spaces will be unused by that processor. So we will go through it with some example. In the same way, rounding up. So if there is cases where memory allocation may be rounded up to nearest block size to simplify memory management, this also leads to internal fragmentation. So let's take an example to understand the concept of fragmentation. So suppose there is a process and this process requests 18 KB of memory, but the system allocates memory in 4 KB blocks. So basically the system will allocate the 4 KB block of memory. So what's the point here? That suppose the processor is requesting, or some process is requesting 18 KB of memory, but the system is designed such that it will allocate the memory in 4 KB blocks, right? So this 4 KB blocks will be allocated. Each block will have 4 KB of memory. So what will happen? That the system will reserve 5 such blocks, because 5 you multiply with 4, that means the 20 KB memory will be required to allocate the 18 KB request that is being made by some processes. So the remaining 2 KB of internal memory is being reserved but of no use. So this is one of the example that indicates how the internal um, fragmentation may happen uh, while a system is requesting, or a process is requesting some memory from the operating system. Now let's try to understand the second type of fragmentation, which is external fragmentation. So external fragmentation occurs when available memory or storage space is fragmented into multiple small non-continuous blocks. So this fragmentation can make it challenging to allocate the large continuous block of memory for a process or a data. So the primary cause of external fragmentations include process loading and unloading. So when a process are loaded um, into the memory, and then it unloaded from the memory, so they leave behind certain fragment spaces. So this can result in the scattered free memory blocks. In the same way, when we perform different file operation, like when we perform creating, deleting, and updating operations on the file, this can also contribute to the external fragmentation, because the files are created or deleted, so the spaces are becomes like available, and they are fragmented. In the same way, another reason for external fragmentation is the memory allocation pattern. So the way memory is allocated and deallocated by some programs, like some programming languages like C and other languages, they provide the memory allocation concept. So the way the memory is allocated and deallocated can affect the likelihood of external fragmentation. So let's take another example here to understand the concept of external fragmentation. So you have certain blocks, and these 16 KB memory space, they are being scattered with 4 KB blocks, right? And suppose some program is using only 3 KB of the space, and this 1 KB is available free, but this free space is available but they are scattered. So this is the problem that will leads to external fragmentation, because you cannot use these free spaces. These free spaces are available but they are scattered. So if you want to store some data which require 4 KB of memory, let's say, so you cannot store it in these spaces, because these are free spaces of 1 KB each, but they are all scattered. So these are some of the challenges related to the fragmentation. So when we perform different types of operations, so fragmentation might occur, and we have to deal with this issue. So how to deal with this issue? So we have something called compaction. So compaction involves reorganizing the memory or storage space to consolidate the fragmented blocks. So it basically creates large continuous free area. So as you have seen in the previous slide, so we were having spaces, but they are all scattered, right? So when we apply the compaction, basically it helps us to create a large continuous free area, right? So all those free areas are being basically available, and these are joined together. So this process involves like moving the data from scattered location to a single continuous block. So the primary goal of the compaction is to eliminate the external fragmentation, which occurs when, as we have just seen, when free memory or storage space is fragmented into the small non-continuous block. So by consolidating these fragmented blocks, compaction creates a large continuous area that can be allocated for process or data. So as we have seen in the example, so if you have certain memory space and these spaces are used in such a way that there are some free spaces available. So let's say this is 5 KB free spaces, here we have 7 KB free spaces, and here we may have, let's say, 10 KB free spaces. So when we apply the compaction, so what will happen, that compaction will basically do some operation through which all these free spaces will be available to you as a continuous block. So 5 plus 10 and plus 7, which is 22 KB block of free space will be available for any process to use this free space. So this is the primary goal of compaction, is to eliminate the external fragmentation and free the memory or the storage space and provide you the continuous non-block space that is available to be used for some processes. So compaction can significantly improve the system performance by reducing the time it takes to allocate the memory or disk space. So when memory or disk spaces or some storage, if they are fragmented, so the system may need more time to search for suitable block, which can slow down the operation and performance of the system. So with the help of compaction, basically we can eliminate the search process and allow for more efficient search operation. Let's move to our next topic, how compaction work. So basically there are different techniques. So let's discuss what is memory compaction. So in operating systems, memory compaction is the process of moving process within the memory to consolidate the free memory into one large continuous block. So this technique helps organize memory usage by eliminating the fragmentation spaces, so allowing for large memory allocation for new processes. However, memory compaction techniques required halting the execution of the process, because now you are going to copy the data to some new location and update the memory references to ensure the consistency. So that's why this type of technique of compaction sometimes required time consumption operations, and it might temporarily disturb or disrupt the system performance. The second approach, how compaction work, is the disk compaction. So for storage devices, compaction refers to the process of moving fragmented files to continuous block on the disk, so commonly known as defragmentation. If you recall, in our previous sessions, we have briefly discussed the concept of defragmentation. So over the time, files are created, modified, deleted, and data can become scattered across the disk, leading to inefficiencies in read and write operations. So disk compaction recognizes the data, placing the file fragments next to each other to improve the access time and enhance the overall disk performance. This process is particularly important for traditional hard drives, as it helps maintain the optimal data retrieval speed. Compaction technique, swapping is another technique. So in swapping, what happens that the processes are temporarily moved to some temporary disk. We call it like some designated area, like a swap space, and then return to the memory in a compact form. So this process allows the operating system to free up the memory by consolidating the active processes, enabling more efficient use of available resources. Another technique of compaction is the garbage collection. So in managed environment like Java and .NET, garbage collection can include compaction as a part of its operation. This techniques helps reduce memory fragmentation by reallocating the objects within the heap to create large continuous blocks of free memory. So by doing so, it optimizes memory usage and improves the performance, particularly in long-running applications. Defragmentation tools, as we have seen some of the tools in our previous session. So in most of the operating system, there are ready-made tools available to perform the defragmentation on the hard drive. So utilities are designed to rearrange the fragmented data on the storage devices. So these tools, basically, they are capable of analyzing the storage and move the file fragments into the continuous blocks. So this enhances the read and write performance, and by minimizing the distance of read and write head must travel on traditional hard drive. So let's move to our next important concept. Like when we have fragmentation, so how it affects the performance. So memory fragmentation, so high fragmentation in the memory can significantly hinders the performance by leading to a poor memory utilization. This inefficiency often resulted in a high paging activity and increased the CPU usage and reduced the system responsiveness. In severe cases, memory fragmentation can cause the system to run out of memory, even when sufficient total memory they are available, but they are available on scattered spaces, right? So that's the reason, even though the memory, some spaces are available, but the system will show that the system is running out of memory. So so we can see that if we have fragmentation, so how it hinders the performance of your computer systems. In the same way, the storage fragmentation, as we have discussed earlier, so on the storage devices also, particularly we're talking about the hard disk drive, the HDDs. So we see that these drives become so slow in read and write operation because of the fragmentation. So when data is fragmented, the read and write head must move back and forth across the disk to access the scattered pieces of information. So this additional movement increases the access time, leading to the slower file retrieval and overall system performance. So fragmentation can therefore contribute to the sluggish user experiences, especially when opening like very large file, or maybe when we are retrieving some data which is on heavy on the disk access. So let's also discuss the benefits of compaction. So there are many benefits. So basically it improves the memory utilization. So compaction effectively consolidates the free memory into the large continuous blocks, which enhance the utilization of the available memory. By minimizing the fragmentation, it reduces the need of paging, allowing process to run smoothly, efficiently, and providing all the improved system performance. Um, in the same way, another benefit is enhanced disk performance. So defragmentation of disk significantly reduce the seek time and improve the data access speed. So by organizing the fragmented files into the continuous blocks, the system can basically retrieve data more quickly, leading to enhanced overall performance, particularly in the system that rely heavily on the disk storage. Also, the another benefit is the reduce overheads. So, compacting the memory decreases the overhead allocated with the memory management, such as the complexity of tracking multiple small free memory blocks. So this significantly allows the operating system to manage memory more efficiently, resulting in the lower CPU usage and improve the system responsiveness. Memory fragmentation and compaction in the operating system. Windows operating system, Linux kernel compaction, all these operating system basically provides you some ready-made techniques through which you can um, automatically enable the compaction. So for the case like Windows operating system, so it employs various techniques to manage both the internal and the external fragmentation. So the system periodically executes some background task to compact the memory and reduce the fragmentation and optimize the memory usage. Additionally, um, there are some tools available for disk defragmentation. Uh, we have already seen those tools in our previous session. So these tools helps reorganize the fragmented files on the storage device, enhance the overall system performance, and ensuring the smoother operations of application. In the same way, if you see the Linux operating system, so the Linux kernel features built-in compaction mechanism that actively move the memory spaces to create the large continuous memory region. There are some third-party tools that are also available, and these tools are having more advanced features for disk fragmentation and performance optimization, like defragler, smart defrag, and my defrag. So these tools are very handy in performing the disk defragmentation and performance optimization of your disk. So by utilizing specialized tools, as we have just seen those examples, user can enhance the efficiency of their storage device, leading to improved read and write speed and overall system performance. Now, when we see certain applications of the fragmentation and compaction, database management system basically are some such systems that manages, store, create, update huge amount of data. So these type of data systems uh, have database fragmentation, and also the compaction in the database management system support is available. So in database management system, fragmentation arises when records or data pages are not stored continuously. So this lack of continuity can lead to degrade the query performance. So when we use the database systems, normally we perform certain queries. So queries are basically certain questions that you are asking from database to provide you some sort of like data. So if I want to know, for example, how many students are registered in this course, so I will just perform a simple query from my database, and the database will provide you the students' details. So when we have the fragmentation in our database management system, so again the retrieval of these query performance will be affected. So system may not provide you like the best results, because your data is fragmented maybe on multiple disk locations. So to retrieve those data, it will be very challenging, and that resulted in the slower response time and increased latency during the data retrieval operation. So most of the database tools provide the compaction, because as we have already discussed, the effect of fragmentation, we have to apply certain techniques to overcome these issues. So to enhance the performance in your database system, you have to use certain techniques. So one of the techniques is basically called indexing. So when you perform indexing on your tables, so it basically helps you to retrieve your record efficiently, and it reorganizes the table. It basically consolidate the fragmented records, and it defragments the table space. So overall, you can see that the concept of fragmentation and defragmentation, they are there in most of the applications, whether those are database related applications or some file based systems and so on. So there are some limitations and challenges of compaction. So especially sometimes the compaction process takes time. So as we have discussed earlier, so because what's happening that when you have like a large system and subsequent amount of data, so the process of compaction basically moves the data from one large continuous area to another area. So this will take a lot of time. So basically this technique is time consuming. And also when the system performs these type of tasks, so it requires the system to halt or pause certain execution. So the processes that are executing, or some operations that are performing, so those have to be paused. So this may interrupt the services, some real time, for example, some mission critical applications if you are using. So so these pauses and these halts may result in some system issues. So these are some limitation and challenges of compaction. And also not always this technique is effective. So compaction basically does not guarantee the complete elimination of fragmentation. So because the new fragmentation can occur rapidly due to the frequent memory allocation and deallocation, rendering the benefit and the compaction uh, that we have used. So basically, we have to use some dynamic environment where these operations can be performed seamlessly. So in conclusion, fragmentation and compaction, they are the fundamental concepts in memory and storage management, and they significantly influence the system performance and efficiency. So fragmentation can result in the wastage of space, and also it reduces the performance. So while the compaction addresses these challenges by consolidating the free memory or storage into the continuous blocks. So a truly understanding of these concepts is essential for developer, for system administrator, or for IT professionals who are tasked with optimization and maintaining the system resources, ensuring the smooth operation and enhance the overall performance. Now let's move to our last topic, um, some common computer troubleshooting steps. So let's try to understand um, what is basically uh, the computer troubleshooting. What is the meaning of computer troubleshooting? Okay, so computer troubleshooting is basically it's a process, it's a systematic process of diagnosing, identifying, and resolving issues that may arises within your computer system. So this process involves a thoroughly examination of the computer to pinpoint the root cause of the problem, which could be related to hardware, your software, maybe networking, or some other system component. So when we follow certain structured approach uh, or some well-known techniques, so we can basically resolve, or we can implement some appropriate solutions, ultimately restoring the system functionality and optimizing its performance. So now let's go through some of the common computer troubleshooting steps. When we have certain issues in our computer systems, like maybe you see that your system is not um, performing well, it's not very responsive. So the best troubleshooting step is to just restart the computer. So restarting the computer is one of the simplest, but it is the most like effective troubleshooting steps, because it clears the temporary files. So it resets the hardware components, and it refreshes the operating system. So sometimes by just restarting the computer, we see that certain minor glitches or some software conflicts that may hinders the performance of the system, it is basically gone when you just restart the computer. So this is basically the most simple uh, but effective troubleshooting step, that we just simply start our computer system. Now the second important troubleshooting technique is uh, to start your computer in the safe mode, which is also called like booting the system in the safe mode. So safe mode is basically a diagnostic mode that allows the computer to start with only the essential system files and drivers. So this minimal environment is particularly useful for troubleshooting certain issues related to maybe software, maybe some driver conflicting issues or some malware infections. So by limiting the operating system to its core component, we can easily diagnose the issues that might be affecting the performance of our computer system. So safe mode helps users identify and restore the problem, and maybe preventing the normal operation, facilitating like a more focused and effective troubleshooting process. So when you should use the safe mode, so you should use the safe mode when you, for example, encountering some issues related to startup. Your Windows is not starting. There are some driver conflicting issues, maybe some suspected malware infection. So these are the issues if you have in your computer systems. So you can use the safe mode. Of course, if the problem does not persist in safe mode, it suggests that the underlying issues may be related to some third-party software or driver or some services that you have installed. So now let's move to the next topic. Sometimes we see that when we install certain softwares, certain updates, we see that my system start behaving in a different way. So the best way to overcome these type of issues is to uninstall these newly installed system or software, or maybe some updates. In the same way, as we have just discussed, that sometimes what happens that when you installed certain updates or maybe some drivers that you recently updated, so you might see that there are issues related to system inability, or compatibility issues might happen, or sometimes the conflicting issues may occur because the program or the drivers are already there. So these type of issues, if they exist, if you installed some new updates in your system, that might create a lot of problems in your computer system. So the best strategy is to basically remove or uninstall these new updates from your computer system. Now, the other most common troubleshooting step is sometimes we see that our peripheral devices or maybe our network, they are not responding. So it is important for us to check the cables. Sometimes what happens that these issues occurs because of the cable that is maybe not properly connected, or maybe the cable is damaged. So if you have any issues related to your peripheral devices, so let's say your keyboard, your mouse, your mic, your camera, and so on, or sometimes your network is not working. So we have to see our network cable, and if we see there are any issues identified, we have to fix those cables. So any faulty cable that you might found while you are troubleshooting the issue, you have to replace it with the new cable. All right. So again, when to check that you have some issues related to the cable. So this is only when you are experiencing certain problems, right? As I just mentioned to you, that while you start your computer, you realize that the display is not very proper, the keyboard is not responsive, the network, some external, for example, devices are not responding. So you have to see if there are any issues related to your cables. Now, another important troubleshooting step is regularly updating the drivers and the operating system. So we have discussed this in the previous sessions also, that it's so important for us to regularly update our operating system as well as our drivers, because when we update our operating system, so most of the features are being updated, and also if there are certain issues related to the performance or some security vulnerabilities, all these are being addressed in the updates. So as soon as the certain vulnerabilities are being identified, those are being addressed in the updates. So it's so important for us to keep regularly updating our operating system. So sometimes um, while you use some new hardware, or sometimes if the system crashes also, so these are some indicators that you have to go and update your operating system as well as your drivers. So we have gone through some of the basic troubleshooting techniques, because these techniques are vital for diagnosing and resolving some common computer problem. So by systematically following these steps, like restarting the computer, booting it in the safe mode, uninstalling problematic like software or certain drivers, checking the cables and running malware scans, and also like cleaning also our disk space, and regularly updating the operating system and the drivers. So these steps are required to ensure that you have your systems that are up to date, and if there are any issues, these can be resolved. We reached to the end of this week topics. So we already covered all the important concepts. So now let's conclude this week's topics, that what we have covered so far in this week. So we started discussing about the computer maintenance and security. So we already have learned that computer maintenance and securities, they are essential for ensuring the smooth functioning and longevity of any of our computing devices. Also, we have discussed regularly updating the devices drivers is crucial, because it facilitates effective communication between the hardware and the software. So it also prevent any errors or system crashes. We have also discussed the important role of antivirus softwares, because these antivirus software provides a vital layer of protection against malware and cyber threats, safeguarding personal and sensitive data. So by prioritizing these aspects, user can enhance their system performance and security, leading to more reliable and good computer experiencing. Furthermore, we have also discussed how disk cleaning utilities optimize the storage space and improve the system performance by removing the unnecessary files. Also, we have discussed the computer diagnostic program like DirectX, which plays a crucial role in identifying and resolving the hardware and software issues. The use of DirectX contribute to the overall health of the system. Also, we have discussed the role of disk fragmentation and compaction, because they helps or organize our data efficiently on the disk, enhancing access speed and preventing slowdown over the time. So together these practices, we can have a safe, secure, high performance computing environment, minimizing the risk and extending the lifespan of both our hardware and software components. So this concludes our this week session. In the next session, we will go through some important concepts. If you have any questions or topics you would like me to discuss, so feel free to contact and reach out to me. Looking forward to our next session.